Yes, I'm ready.
Is it working?
Yeah. Okay. All right. So, hello again. Hope everything's good. Okay, there you go. It's sort of, yeah, that looks good. All right. So, yeah, with the presentations, I guess everyone's been preoccupied with their mini projects, which is why we didn't get anyone to volunteer for today. But yeah, I was a bit alarmed by that because we need to, we need to use these slots, else we're going to run out of slots, and I want to make sure everyone has a chance. So, but luckily we have a last-minute volunteer, so we'll at least have one presentation. You're going to talk about your mini project.
Yeah,
that's great. So yeah, that was something that I forgot to suggest, which is of course talking about what you've been doing. And your mini project is a great option. And later on, talking about what you're doing for your final project as well is another good option. So let's hear the talk, and then we'll talk about the practical for this week on sinusoidal stuff. Looking forward, yeah. So yeah.
Hello everyone. Hello everyone.
Yeah.
I think that there's not available today, so I would like to present my own mini project. Although it's simple, but I think I can give you a general idea of how this project can be done, and if you haven't do it, you can just borrow my idea. So I will first show you my interface. Actually, what I did is it's very similar to the interface on the website. So now I'm going to show you how we can do this step by step. Firstly, we need to do one thing, is that to convert the piano key, to convert a certain frequency into a piano key. Here we can see we have an equation that is can convert the frequency of each FFT into the piano key. So firstly, we can do this to get every time you get a fundamental frequency, you can convert it into a. Yeah.
Can you make that any bigger? The video screen's on. It's too high. Too high a scan rate for the secondary screens. Can you reduce the resolution on your screen?
If you press Control Plus, it might be
I know it would be nice if we get it to come up on these screens as well.
Yeah. Does it work?
Can you make it like is a low resolution?
I think.
I can read it.
Yes. Here we can see an equation that can convert each frequency you get into the piano key number. On the website, we have a piano key from C3 to C6. We can see that each frequency is here, and the key number is here. What I did here is to write a lookup table. Lookup table that actually is every time you got a piano key, you look up for the string, like key 82 corresponding to string C3. So you when you call this function, you give the key number back to your control part.
Sorry, converts a frequency into a key number,
Or convert the key number into a string, like key 28 corresponding to string C3. So we first by doing this, then we then these two lines are doing how we can. I'm sorry, it's too small. Front side. Here we can see these are two sentences of how we can convert the, like say we have a frequency, we have the fundamental frequencies at the FFT frequency band J. Then how we can convert this into the frequency? Then we use this equation. We use sample rate divided by buffer size. That is the step size of each frequency interval. Then we times J. Then we got the frequency. Frequency we have in the fundamental frequency band, and then we convert the frequency into the piano key number by doing this. This is just computer language expression of the previous equation I've shown you. This is just this equation I will show you. So after doing this, now you can draw. After doing this, now you can draw. After doing this, you can just draw a line on the original screen, just like what the original program did. How to draw a line in the screen? There are actually in the program there are two loops. The first loop is to find out the maximum, so that is the fundamental frequency. The second loop is to do highlight the original color in green. Now we can just keep the first loop, but eliminate its output, so that we can still find the maximum frequency. Then the second one, we do some modification. Second one, the modification is that we use the piano key to replace. Is
there a closing error?
Yeah, it's I don't know what I typed, so. Actually, finally we can. Finally, we can change this line, this original red, green line to something like a red rectangle, so that it's just to represent the C3 to C6 on the screen. So finally, this can be done. So how to draw these lines and dots and this kind of text on the screen? You just use for loop, and every time you specify a location, coordinate. You draw one by one, and finally you can do this. This is not very difficult, no big deal, but I think it gives you a good idea to how to do this project. That's it.
Great, thank you. Any questions?
I just wondered, how large is your buffer size?
Yeah, my buffer size is 1024. Yeah, one thing I forgot to mention, that is I originally buffer size 1024. I didn't change buffer size. I used the buffer size divided by the sample rate to calculate the time access, but it turned out to be incorrect, so I deleted them again. So, do you have any other question?
How well is it doing at picking out the piano notes?
I think I changed the interval from 5 to 2. Then it's can pick out like 80% correctly. I think 80%. I because I have no background in music. Every time a sound, the key sound, I don't know what it is.
And that's the sort of the biggest. I mean, did a really nice job making the display. That's really great. But the problem is the what's being rendered on display. Right?
Yeah.
Which is what the notes that you find are, and that's
really a big problem for people who have no background in music. So.
Yeah.
So I tried to implement the methods on paper, but it's turned out too complex.
Yeah. I know. Just in general, I mean, you can spend. There's quite a lot of mileage in just playing the thresholds and stuff to try and think that out. Okay, great. Well, thanks very much. And in particular, thank you for stepping in at the last moment. I realised that it's not like you didn't have any time to set everything up. Yeah, it's all a bit. It's surprisingly hard. There are two things surprisingly hard. One is to make the display that you're used to working with on your machine be legible in this kind of situation. Another is when you're trying to show something live, right? And your mind is divided between what you're saying and then like, wait, what's going on my computer? So it's an interesting experience to go through. Okay, so okay, you've still got my microphone on, I think.
I'm sorry.
Okay. So now we can this is practical. So on Monday we were talking about sinusoidal modeling, and I showed you briefly the patch that allows you to take the sinusoidal parameters extracted by Spear, by that program that converts figures out the sine tracks, and then read them into PD and use them to play back. So I want you to do the same things we did last week of breaking up into teams. Seems like we don't have as many people here as we normally do. I guess people are using the time a different way. But anyway, so we've still got enough for a few teams. And so there are a few things to try. So let me just show you this patch again. The basic patch. And I've put in a couple of changes so that you might, if you've downloaded it before, you might want to just get the latest version from the website. Hang on, I need to turn. Just a second. Where am I going to get? I always have this thing that once I plug the screen in, then my menu bar gets so small I can't get the control to get the sound back up. What's happened? The sound's gone away anyway. Okay. Does it work? Okay. So this is the patch, and what it does is you click this here, and it brings up a file selection box, and then you can find one of these files that you've saved from Spear here, read it in, and it tells you that it read in 39 partials and there were 257 frames, which I guess is I think they're 10 millisecond frames, that's 2.6 seconds roughly. And then when you click this, yeah, it runs the synthesizer. So what it does is, so each in this data file, in this Spear data file, all it is, as we saw before, it's just a text file with some header information, and then for each time frame it says how many partials there are, and then for each one it has an index, a frequency, and a magnitude, and then the next one, here's the index of it, frequency and magnitude, etc. So what this patch does here, the one to load in the file, it actually just this is text processing in PD, which is not the most convenient thing, but essentially all it does is it reads in this text file unit, reads in the file line at a time. How does it do this? It basically decides whether the line is a header or not. If it's a header, it pulls out these two fields, partials count and frame count, and because it wants to know those, it's going to need those later on. And otherwise, it takes the list and breaks it into pieces. It's a while since I wrote. I did write this code myself, but it's been a while. And so it just breaks it into pieces and writes it out into two arrays. It basically writes out an array with all the magnitudes of all the tracks and the frequencies of all the tracks. Is this even the right version? Yeah, I guess so. And then what happens when you run the playback? This thing just sends a bang message, and this thing just counts up from 0 to the number of frames. And so basically every time the metronome here, every 10 milliseconds, it sends a new bang here, and this is just a little kind of like a latch that every time it gets a bang, it updates itself to be what it was last time plus 1. But then it waits until the next bang to increment. This is how you do a counter in PD. And then that message gets sent to the time channel signal, which then selects which frame. And so now each of these instances of my partial synthesizes one partial. They get given this number here as a creation argument, which shows up as $1 within the patch. And so it receives the time flag here, this thing that was sent here. They all receive that at the same time. And then what it does is it knows how many frames there are for each block in the table, multiplies that by its creation argument, so it'll basically start at the nth block in the table, then it adds on the current time, and then that becomes the index of which point in the table to read, which point in the frequency table, which point in the magnitude table. And it reads from these tables here. It does a line interpolation, a straight line interpolation of the frequency and magnitude. The frequency value gets multiplied by the frequency scale and passed the oscillator. The magnitude value just gets passed as the multiplied by the output of the oscillator, and then that output now is our scaled sinusoid, our amplitude scaled sinusoid of the appropriate frequency, which it gets thrown into this thing, a sum bus, which is just a mixing bus. And so here you have, it gets the result from the summing bus. All the things that get thrown to that get added up, and it just gets written to the audio output here. So each one of these my partial instances generates a different partial, and the reason they're different is because they have different values of $1 here, right? Different values of this argument, which then means that they look in different places in the tables. And the tables is like, 257 values for the frequency of partial 0, 257 values of the frequency of partial 1, etc., etc., etc. And same for the magnitude table. So they all pick up the corresponding frequency and magnitude values for one of the partials from the file, and then as time steps through from 0 to the end, the number of frames, it picks up a different value in here. This stuff over here is displays here, and what it is, this is just because as it stands, the order that Spear writes out these files is kind of random. That writes out the partials. I think it's actually in the order that they're first detected, but that's typically not that relevant to us. And so you've got 32 partials here, but it's difficult to know which one is which. And of course you can turn them on or off, but you sort of have to do that at random, which would be kind of frustrating. So this thing actually records the average frequency and the total energy of each partial after it's played. When we load a new partial, they get reset to 0. When you play, it's sort of on the fly, it calculates the energy weighted average of the frequency. And so now you can easily find that, well, these ones are all very high frequency ones, but down here there's a lower frequency harmonic. So if I turn all these, if I turn them all off with this flag up, with this signal up here, and then turn on just this one, the 300 hertz one, then I've got a low harmonic. Is that the fundamental? I think it's the second harmonic. I'm not seeing the fundamental, maybe the fundamental fell off, but you can add in a few of these low frequency ones and you get an idea. And so the logic to do that is what we're seeing here. It's not that, it doesn't really matter what it does, it just sums up the product of the magnitude and the frequency, sums it up here, and then divides it by the sum of the energy to get the average frequency. And this stuff down here, I don't know what it does. That's just debug or something. So that's the general idea. So we got all these things, we can control them. And then, oh yes, in here we have some more signals. So it's receiving the frequency scale in here, which we can change with this scaling thing here. It's receiving a time scaling in here, which actually both changes the time base of the metronome, so it changes how rapidly the metronome increments the frame count, but it also changes the time associated with these crossfade messages, so that as you slow it down, not only does it update the frequency and magnitude less often, but it allows them to crossfade more slowly, so you still get a smooth evolution, which is sort of a detail, but that's all it takes. So basically, in order to change the time scale, we just slow down how rapidly we increment here, and then to change the frequency scale, we just send this flag to the individual partial instances that just multiplies the frequencies by a value. So that's all it takes to build a sine wave synthesizer once you've got the analyzed data. So here are the things that I'm suggesting you can try in your groups. You can try instead of just having this driven by something, a button that you click, you can actually have it try and drive it from the keyboard unit that we had last week, where you press a key on your keyboard and it plays a note. Then you can try and control the frequency in relation to which key is being pressed, so you can actually play back these samples on like a keyboard. You can play with the frequency modifications. So now that we've got the sound described by individual frequencies and magnitudes, the different harmonics, we can do things like saying, well, what happens if we offset these frequencies or scale them in a non-linear way? What does that do to the sound? And you can actually listen to that effect. We can also do things like varying the frequency as the sound is playing to give it vibrato. You could try seeing how that sounds. If we were actually trying to build a keyboard, something where we could just play it like the analog synthesizer, one of the problems here is that basically you play the sound and it starts playing until it ends, right? Whereas normally you want to have some control over the duration of the note based on when you press and release the key. The way you'd have to do this for this kind of sound would be to have a loop region, a little chunk in the middle that just repeats for as long as the key is held down and then starts playing. So you could think about how to implement that and have a go at that. That's quite a significant modification. Another thing you could try is obviously using Spear to analyze your own sound and feed that in and see how that works with these kinds of effects. And I've actually written some functions to load the Spear file into MATLAB and to write it out again. And you can actually, within MATLAB, just becomes there's one matrix which is all the frequency values, one matrix which is all the magnitude values, and you can do things like rearranging those or pruning them or whatever. This file here, guitar rewrite, git rewrite, is what I did in MATLAB. And the point about that was it's the same sound, but I sorted the harmonics by magnitude, by total energy. And so that means that the first ones are the more interesting ones here. So that's kind of a nice thing you can do. But I didn't change the data. Of course, you could actually change the values of the data. Okay, so any questions about what to do there? All right, so please form into the same groups like we had last week. So I think it's good to have 4 or 5 people in each group, and then we're going to do this for half an hour, and then at the end of that we're actually going to have someone from each group come up, or each group as a group come up and just talk about what they've been doing and what they found out. Okay, so please be thinking about what you're going to say at the end as well. I know. Yeah, I know. But the thing, this one's a lot easier to read.
Yeah.
So I thought I'd leave a simple one up there because you've got a chance of figuring out what it actually does.
Yeah.
Well,
This is more like
yeah.
Sometimes it's difficult to really debug what's wrong with these key patches.
Yeah, I'd noticed that. So this one does this error message, right? When I run it, it says inlet expected flow, but the list somewhere there's an inlet where I'm feeding it a list when it's supposed to get flow, but it's like how can I find it?
And it says you can find by clicking find button, but when you click the find, it says we cannot locate that error.
Oh, really?
Yeah. If you go to the patch and patch that
Yeah.
generate error, but I don't think it works most of yeah.
Find last
find
error.
last error. Yeah.
Oh. So that's interesting.
Yeah. Can you go to the comment?
Track all error.
Lost.
Oh look, here it is. Oh my goodness.
really?
Oh, that's great. Yes, it's highlighted. Yeah. Oh wow. How did you know? How did you find that out? How did you?
Yeah, I looked at this message
Yeah.
and they told me to look for the find error.
Oh, that's great. Oh, that makes a lot of sense. Okay. So this thing,
Mm-hmm.
that's interesting.
What does it do?
This is like it reads through the file
Right.
until it it pulls out that one line. So it's obviously getting I guess
Oh yeah.
it's coming out there because basically it looks for this header line
Mhm, mhm.
and then it
Goes.
tries to store that number.
Number.
It appears to succeed in storing that number. So I'm surprised at this. Yeah, I'm not sure. Let's see what happens there. That's great. Print back. Wait. Okay, that doesn't seem to be right at all.
So this split is outputting lists, right?
List split. Two. I don't know what that does. Split list in two.
Yeah. And when you have some arguments here, what it does is like.
Yeah, but what is it? Why does it have three outputs? So it should take the first two elements and write them out here, and then take the subsequent elements and send them out here. So here it takes the first two elements. So then
Right.
it splits into two elements into. Right. Yeah. So here's how it works. Right. This thing now is a set of pairs like partial count, whatever, frame count, whatever.
Mhm.
So now it takes the first one of those and it checks to see, well, is it partials count? If so, then we're going to get a bang out here, and then it takes the second, the actual value, writes into this float here, and it gets a bang there. It copies that to there. Okay, is it frame count? If it is, then it writes a bang there, and this value again is the one that's stored.
Right.
But for some reason, so here's the bang. But for some reason, when it gets rewind, it also. So where this is.
A rewind is somewhere else. I think you're using print function somewhere else as well. So it's like
And the expected float but got list. Expected float. Okay, so it's this one that should be. Getting
the right hand side inlet, right?
Yeah.
We got a lot of. So these are all the values as well. Symbol index. So these are number of
okay. Yeah, that's it.
signals, right?
So that's what the problem is. For some reason, this thing is getting run on. It's not only getting. Oh, okay. All right. So this thing, it gets whatever comes out of the second half of this list, right?
Right.
And it only stores it when it's when it matches the
This
select.
frame count.
But this is just like
anything that is in the list.
the second entry of the list. So when in the header here,
Yeah.
this is what it's getting. It's getting like it's getting this.
Oh,
thing
this
here.
index.
Yeah,
oh.
so it's parsing this line out, and it's getting the second entry, which is not.
Okay. But anyway, it works because later on it works on the actual thing that we need.
Yeah, so it doesn't
to
actually
run.
doesn't have to store. It never tries to store that value.
So this error is fine.
I know, but it's ugly.
Yeah.
I
Yeah.
don't want you to. No, I don't.
Can we look at this data file? So, but frame count, but there is no frame count in the above. But do they? I mean, does F detect whether it's index or
Yeah, I
float?
mean, so the second entry, the only valid things for. I mean, so every time this just takes a line,
Right.
splits out the first two items, splits them in two, and then, doesn't matter what the line is. It always the second if it's got a second item, the second item always goes down here, and the second input of an F can only accept floats. So it's writing the second entry of every line.
Right. Okay. So yeah, when the second input is not a float, then it just spits some error. Right.
Yeah. And it doesn't matter.
Yeah, it doesn't really matter.
But it is kind of it's kind of ugly.
Okay.
I don't know quite what to do. I think you can you can have something that selects on the type of the input, and so we could have it so that it only
Mhm.
forwards this if it's a float.
Mm-hmm.
But,
Yeah, but it will complicate the.
yeah, exactly.
Yeah.
Oh, that's,
Okay,
I'm
it's-
glad we
it's
sorted
okay.
that out. No, I learned something about how to debug TV there. That was great.
Yeah, I was working on some of the patches, and
Yeah.
it was quite difficult to really.
Yeah.
debug.
No, it's just. Yeah, so
It-
didn't have that help.
Yeah, when you want to implement something that is as simple as counter.
Yeah, right. No, I mean you have to so you have to learn a completely new way of doing it. So it's a strange thing.
I was thinking like there's a fade time modified
It's modifying how long it's like the how long it's thinking now it's make this. So once we have to know once it hits. Once it hits on the fade.
could just like say as long as it's being held to replay. Anytime you change the volume, it doesn't actually change the what happens if the
Okay, okay. Right. You can have something like start sending to some wire like cable which is S comment send cable send comment. So basically what this is doing is every time you play, every time you play it adds something. Okay. So if you want to initialize it, you need to basically initialize the value by clicking. By inputting that like 0 message to every number, in the register. Yeah, that's right. Yeah, one way you can do it is sending some message to each of the small patches, which can be done by sending and receiving. This one is front.
Yeah, this one is.
And this is.
Oh, the next one is down. This one is
offset.
Okay.
Frame count.
So what you need to do is set this one.
We're finished.
No, actually, this is saved somewhere, right?
Not.
It's not the one that I used to.
Yes, I'm function also one that we can initialize
find out and actually this is the first time because most computers actually do they need to change. So
Okay, so in about 5 minutes, I'm going to ask someone from each group to come up and tell us about what you're doing. So please be thinking about what you can say.
any of these, any one of them. Somehow,
Yeah.
What's this blank box? I looked at the help file and it was a toggle, but I didn't. I
Yeah,
don't actually know
which
what that
one?
means. This one, this blank box.
Yeah, so this is just, this is the thing that either holds a 0 or 1. And so when I hit it here, it becomes this X, which means it's outputting a 1, and then when I get to the end, I send this 0 to it, which makes it stop it, and then the metronome only runs when that thing is
Oh, okay.
set.
So it only runs when. Okay.
And that's when I use that to sort of to run the thing. I sort of have this thing where I set it to 1, and then when I detect that I've hit the end, I set it to 0. That's how I stop it running.
Okay.
That's the point of that.
然后再加一个 P， 然后放 P 它对象是大怎么样我想把它调整起来。
就是没声音吗？
这个是 X， so the X means it's sending numbers that should be count. And then the X. Yes. 加个
你这样子勾选。
那我们的场景，然后长椅，然后。
Yeah, so it has 0 and so the Xbox is there.
Yes, number.
So what I just tried is.
oh, those diagrams create because can you see the directory where this because actually there's no load balance in that directory.
它就是 number box。
You didn't download it, doesn't it?
This is select 13.
Load bank, sense bank when the source is loaded. So it is like
So when you hold it down.
yeah, start what is it called? Start translate of this. So when it goes, it sends a bank to here. So it sends one to this vertical X, and it is set here. It is set to so
它主要在它指标上的数字。
Yeah. So you have to close the pen and then reopen to let it hang.
你不是朋友写诚实吗？
对哦，他那边就有个小报纸。
Reopen. Then it hangs. But if you
我有的地方看不是写的，他让写的。
patches.
为什么就之前那个那个查改这样？但是搞笑的是这样的改，你咋知道原来是改的？
How can I edit the models? Edit the oscillator.
Oh, you mean the my file? You have to open it from this file browser. My password. Double click. You need to if not lazy.
Yes, not lazy.
Open would be very open.
Because I didn't install it, I didn't install it to the system.
What it is.
就是我猜的。这句声音太短了。
In where?
没有，然后你不是把这个推到上面去？
他是没有吗？
Oh, okay.
它就是这个意思。
Okay.
啊，它就是把不是变了啊。不是变了，不是没有变。
Professor.
And then,
Yeah.
Something new.
when you
So I was trying to do it, try to just control the beginning and the end using a key and a key up. But obviously when you hold on the key, most computers do an auto repeat.
Yeah.
Do you know is that any way to get around?
It should be in the control panel somewhere. I think the keyboard control.
Because I looked at it, well, I don't, maybe it's different for Mac, but like I don't know if Windows can do
That's where
it.
it is on the Mac.
Because it does have,
Keyboard control panel.
it does have like repeat, but you can't like turn it off. I can make it longer.
Oh, that's funny. Yeah. And the Mac one end is off. Okay. I guess you can't. In that.
看它原来那个是1到1到
so and then I think this value is something like
Is it max?
你要把它小是吧？
肯定要变小的，因为它这个给的值才是个0.几到1嘛。
so the way usually we do calculation is just average.
Okay, let's have some let's share some experiences. So, who would like to come and tell us something about what they've been doing? All right, what have you guys been doing here?
So we were trying to do the looping, and so we were looking at the different ways that processing handles keyboard inputs just to use a key. So there are two basic ones that we were looking at: key and key up. Key activates every time a key is pressed down, and key up activates every time you release a key. So what we were trying to do. What we're trying to do is basically just use a key press to activate the playback, and then what we got as far as we were trying to use key up just to stop the playback. The problem that I had was that apparently on Macs you can turn off the key repeat, but on PCs you can't really turn off the key repeat. So if you held on a key, it'll just turn it on and on and on and on. And keep on starting it. But imagining that my computer could turn off the key repeat, it would just start it, and then it would end after release. But then the next problem is that as it counts up, then you have the fade, and then you would have to deal with making it not fade so it actually sustains. One of our members somehow accidentally that there was a bug that when you press the key twice, it would stop playing the music or the synthesize, but the time counter wouldn't count. It would stay at 0, which actually just made it just play forever. So I was thinking of maybe looking at how we could maybe get it to actually stop playing but not count up next. And then
That's
get it to start
interesting.
counting once you release the key. So that's basically
Yeah, so the actual, I mean, these oscillators, I guess they're running the whole time. And so the actual, if you control this counter, this time thing, by some other mechanism, so if we just have a symbol, a value here, and if we just send it to time like this, it just takes the 100th frame and runs all the oscillators for that thing. So it's like it's a frozen sound with this fixed spectrum. But you can get it to work like that. That's interesting. Great. Okay, who else? You guys want to tell us something? Sure.
Well, what we did is we try to use keyboard to control the frequency and of the sound. And actually, it's not very hard. And we just put a key object, and then there's keyboard key is to here, and try to use keyboard to control this F scale. Then F scale, that this parameter, I think it can control the amplitude of the frequency. No, not
The value.
Value of the frequency, yeah. And we use this key to we use the object key to control that value. And but here's the problem: the key. I don't know. Perhaps it's the ASC code or something. But A equals to 97. So in the program, in the patch that we use last week, and A equals to 97. So we must.
Sorry.
We have to make it smaller, so I can.
Oh, right.
Yeah. And we can use both key and this to control that. There must be some matching between the button you actually press and the value you want to get. So, but I don't know that because I don't know which note the piano. I use violin. I don't know which note is played. So.
Okay. So yeah, that's great. Thank you for those tips. So here, I'm trying to do what you were doing. I don't know if I'm stepping on anyone else's work here. The keyboard thing was the thing that we had, the synthesis. It actually sends two element lists as messages. It sends a note value, which is a MIDI value, so 60 is middle C, and then it's one semitone. It sends a velocity thing, which is 1 or 0. So here, I'm just picking out, I'm trying to pick out the 1 values by throwing away the 0 values. Which it says if cell 0 will send the zeros out here and everything else out here. So it just sends the things which are not 0 and sends them to the key press. And the note value, if it gets a MIDI value, what we want is natural ratio here. This is natural multiplicative scale. So this is in a log scale. So I convert it to frequency using MIDI frequency. So now I get the actual frequency of the corresponding note, which is still a large number. So now I divide it by 440. So now it's the frequency relative to 440, which is midway. And then I send that to frequency scale. So now it should do the right. This number will be a small thing, and because these numbers are in the right. The keyboard maps these into a sensible range of MIDI numbers, and then it gets scaled into a sensible frequency. So that sort of works. It's not. It doesn't re-trigger very well. Right, so if I press that, it'll play to the end, and then I have to wait until it's finished. But then it will. I guess if I made this faster. Oh, that was the wrong way. Great. Okay, yeah, please.
So, I was trying to add
values never changed. And so I was trying to go through my partial and figure out where that happens. And that's about where I got to. So I added, right here, basically just another plus, and then instead of F scale, F added.
Yeah.
So you could add more slider bars and
Yeah.
stuff. But I never did figure out exactly how it's getting these frequency values and maybe how to display.
Oh, it's not completely clear. What do you mean? Yeah. Until this morning, I had the version on the website that didn't have these update things, which is the thing. The actual screenshot on the website is this without the updates. And I thought, no, these things are important. But then I remember why I didn't put it on, which is why putting them in makes this thing completely unintelligible. Of all the mess of things. Yeah. We need to establish better reading conventions. What are you guys doing?
What we guys was trying to do is, because it's not required, if we go in again to play it back, this one is a down frequency and it is the corresponding energy. But every time we play it again, will be added a number adding energy, so it's not accurate energy that is shown here. So all we are trying to do is to add five partial. We added by partial the PD because the data is installing the by partial the 3D and then every time we run it and we'll try to initialize the value and then clear it to 0 and run it again and will count the correct number of the energy.
Yeah, so the actual so what this thing does in here
Because I guess it is the value it is installed like it is the frequency this is the energy it is installed but what we are trying to do is to not let it add the historical number of the energy it is calculating but every time when it's trying to calculate the energy is to clear it to 0. Clear it to 0. I'm not sure which is the input.
So this variable in here is the sum. It's meant to be the sum of the energy times the magnitude times the frequency. So we get the magnitude. We get
This is the magnitude.
Yeah, I know.
Magnitude error.
This is the trigger set. Here we go. So it takes this thing, multiplies the current value coming out of the magnitude table and the current value coming out of the frequency table, multiplies them together. So we get a magnitude weighted frequency. And then this thing just gets kind of when they're delayed here somehow. This is clearly a hack. But basically then it gets added on, gets added to the current value here. And this thing then accumulates magnitude times frequency. And then this other one over here, one of them's supposed to calculate the product magnitude frequency. The other one here is just calculating the sum of the magnitudes. And then I divide the sum of the magnitude times frequency by the sum of magnitudes to get the average the magnitude weighted average frequency. But to reset these, I have this signal here, which when this gets a bang, it will reset this to 0. And this gets banged by this signal file read, which gets sent every time it finishes reading the file, so it resets. But what you'll do, you should reset that every time.
Yeah, every time it runs.
Every time it plays the note. And so we need something which would send that. Anyone else wants to talk?
Well, I think explain what we were trying to do. Yeah. Well, we were trying to get it to vibrate the main node, so we were a little bit stuck on it because we were looking at the partial. First, we were trying to work in the partial. Then we were trying to work with the frequency scale and trying to get that to oscillate like within a very small range. That's kind of where we're sitting at the moment.
Yeah. So what are we doing? How are we doing that?
Well, we were trying to hook up an oscillator and modulate, but we didn't quite get it. We didn't quite get it going yet.
Yeah. So it seems like if you do something like...
I think in theory it's sound, it just...
Yeah, sure. If you have something like this...
Yeah.
I
mean, that's basically where we are, yeah.
And then if you could sort of add that in here or something like that, then that would do it.
In theory, get
Yeah.
the
So the problem, it's actually, I had this problem with the low frequency oscillator in the analog synthesizer as well, that OSC generates an audio rate signal, but we sort of wanted to control the control rate signal here.
Yeah.
And so you have to use...
Which is what we're stuck on.
So if you look at what happens in the analog synthesizer thing here, I've got this LFO thing, patch, and this is what it does. It runs an oscillator here, but it has this command called snapshot, which has an audio input and a control output. And so this thing, it samples the audio every 10 milliseconds. And
Is snapshot built into...
Yeah, snapshot is a built-in. That's how you up-convert from audio rate to sample rate. But you could just, I mean, if we copied this, you could have just put that LFO in here, and that would have done that too.
I think oscillator without snapshot sort of works.
Oh yeah?
Yeah.
Oh, if you just feed it straight in. I couldn't, but I can't hook this up, right? Well, if
I'm
I
not
just
sure whether mine is correct, but I have something here.
ask without a tilde, does that do something? No.
Let me- So, not sure whether time is okay.
Yeah. Just like-
So
Mhm.
here, vibrate frequency is like sort of 0 to 10 hertz,
Mhm.
which is very low frequency, and this amplitude is relative amplitude for each of the partials.
Mhm.
So each of these partials have some its own frequency, but this one is sort of 0.1 is default value that I found. It sounds like
Yeah.
vibrato, and this 10 hertz is also
Yeah.
the one that I found vibrato. And let me open this. I think it's overlap. Should be this one. Okay, so when this one gets the vibrate frequency, and yeah, we can just use
Yes.
this oscillator and yeah.
Okay, so you see what?
Not quite.
Because Young-Suk is not trying to modify the Freq scale here, which is a command rate signal. He's actually working at the input to oscillator, which is now an audio rate signal. He can add in the output from OSC, and so that works great. Yeah, that's interesting. That's nice. I mean, that's nice to have it put as a to put as a new set of signals into the partial. Great. All right. Anyone else want to speak? Okay, great. Well, thank you again, and that was good. That's how I want it to be. You know, we're all just trying to find something out, and we all find interesting things. So, thanks for working that out today, and I'll see you on Monday.